To understand the easy way to multiply fractions and whole numbers, it's important to also understand how multiplication relates to addition. Now let's just go back a step and say, forget about multiplying fractions. What about just normal numbers? If I tell you to do something like 4 threes, that's the same as having 3 plus another 3 plus another 3 plus another 3. How many threes have you got? You've got 4 of them. You've got 4 of them, okay? So we know that when we write something like this, we can change it into a repeated addition situation. So now when you get to something that's less familiar, like multiplying fractions, it makes sense then that if I've got 4 lots of a third, then I don't just have 1/3, I've got 4 of them. So I've got a third plus a third plus another third plus another third. Now, you should have already learned how to add fractions before you're up to multiplying fractions. So then it makes sense that we've got 1 plus 1 plus 1 plus 1, which is 4. We have 4 thirds altogether. Now, it might be easier to picture this on a number line perhaps, and say here's 0. If I just draw my thirds, I've got 1/3, 2/3, 3/3, which is 1, 4/3, I can keep on counting. Then if I have 1, 2, 3, 4/3, I'm obviously going to finish on 4/3 if I'm just jumping along. You can also look at it as pieces of pie. So each one of these is a third, but if I've got 4 of them, then if I put them all into the same pie, 1, 2, 3 pieces of pie fit into the first pie, and I've got an extra third left over. So you should be able to translate between 4/3 and 1 1/3 literally by drawing it like pieces of pie. That's a really simple method. So looking at another example then, how do we do 3 times 3/4? Well, we don't just have one lot of 3/4, we've got 3 of them. So we have 3/4 plus 3/4 plus 3/4. Now, if we've got common denominators here of quarters, then we can just add together the numerators and say we've got 3 plus 3 plus 3 quarters, or 9/4. Now, looking at that, let's jump down to the number line here. If we're jumping by 3/4 and we're jumping 3 times, 1 jump, 2 jumps, 3 jumps, each time I'm going along 3/4, I'm going to end up here at 2 1/4. And if you have trouble jumping between 2 1/4 and 9/4 and seeing that they're the same thing, drawing them out is not so silly. Here you can see I've got 3/4 of a pizza, another 3/4 of a pizza, and another 3/4 of a pizza. If I add all of those together, I can squish them together to make a more condensed set of pizzas, can't I? I could take one of these slices and put it over here to fill this one in, so I've got a whole pizza. And that would leave me half a pizza here. So if I take 2 of this one and put it over there, that gives me my second full pizza, and I'm left with just 1/4 of a pizza at the end. So feel free to draw them out if it makes sense for you to do it that way. Now, can we see a quick method or a shortcut? 4 times a third, we get 4/3. Well, it looks like we just did 4 times 1 to get the top, and whatever was on the bottom just stayed there. Does the same method work here? 3 threes are 9, and whatever was on the bottom just stayed there. That's the shortcut method. So, if you know your times tables, you should be able to quickly and easily multiply other fractions with whole numbers. Let's do 7 multiplied by 2/3. On the top, we'll need to do 7 2s. And on the bottom, we have thirds. We end up with 14/3. How about 9 times 5/8? Well, 9 5s are 45. And on the bottom, we have our 8. Quite a simple method. It's then another process if you want to change it into a mixed numeral, but for all intents and purposes, this is generally a correct answer and can just be left like that as an improper fraction if you want.